Hello, in this video we're going to look at a model of statistical discrimination in labor markets. So here's our definition. The use of group characteristics from which an individual belongs to help predict that individual's productivity. If a person's individual characteristics are a perfect predictor of productivity, there'd be no reason to consider the person's group characteristics. Statistical discrimination arises because of imperfect information and is not based on personal prejudice. So here we have a wage setting process where the wage equals the following. T is an individual's characteristics, for example, a person's test score, how a person has done on a particular test. T bar is an individual's group characteristics, maybe the average test score for a group. Alpha measures the reliability of a person's test score in predicting productivity. If alpha equals 1, the person's test score is a perfect predictor of productivity and there will be no statistical discrimination. If alpha equals 0, the person's test score has no value and the employer will only consider the group characteristics. So here we have example 1. Bob's individual test score equals 50 and his group test score to which Bob belongs is 60. The reliability of the test, alpha, equals 0.8. Mary's individual test score is also 50 and her group test score to which she belongs is 60, just like Bob. The reliability of the test score here, however, is lower, alpha equals 0.25. Let's put this information in for Bob's wage setting process. So the alpha here is 0.8 times individual test score 50 plus 1 minus alpha times the group's average test score. So Bob's wage here is $52. As for Mary, plugging in the values for alpha, 0.25, her test score is 50, 1 minus alpha is going to be 0.75 times 60, the group test score to which she belongs. So overall, Mary gets a wage of $57.50. And let's look at this in a little bit more detail. So here's Bob's wage setting equation, plugging everything in except for T, Bob's test score. And I'm doing a similar thing for Mary, plugging in the alpha from the last slide and the 60 for the group's average test score. And just simplifying here. And if we were to set WB equal to WM, we'd find that at an individual test score of 60, if both Bob and Mary got an individual test score of 60, they would both earn the same wage. On the other hand, if both Bob and Mary have the same score, but that score is less than 50, or less than 60, less than 60, Mary will get paid more than Bob. That's like we saw in our last, in the numerical example here. If both Bob and Mary have the same score, but each score more than 60, Bob will get paid more than Mary. So that's kind of an interesting thing that comes out of this model here. All right, let's do another example. In example 2, Bob's individual test score is 80 and his group test score to which he belongs is 100. The reliability of the test is 0.5. For Mary, her individual test score is 80, same as Bob's, and her group test score to which she belongs is 90, which is a little bit less than 100. And here we have the reliability of the test score that matches Bob's. Plugging this information into both Bob's and Mary's wage, we see that Bob would be paid more than Mary. So some intuition here. Although both Bob and Mary have the same test score, Bob receives a higher wage. Because the test is not a perfect predictor of productivity in this case, alpha doesn't equal 1, it equals 0.5, the wages partially reflect a person's group test score. And because Bob belongs to the more productive group on average, he will be paid a higher wage. Mary feels like she is held to a higher standard She would have to score 90 on the test to earn the same wage as Bob, who only scored 80. One thing to keep in mind, however, is that with this wage setting process, workers with higher wages are, on average, more productive. All right, I hope you found this video helpful.